Okay, now we're going to look at practice D, which is potential energy. So we'll look at the first one, D1. So it says a spring with a force constant of 5.2 newtons per meter. So K is equal to 5.2 newton per meter. Has a relaxed length of 2.45 meters. So what does that mean, relaxed length? That means just sitting there initially. So I'll just call that XI for the initial length. When a mass attached to the end of the spring, when a mass is attached to the end of the spring and allowed to come to rest, the vertical spring length is 3.57 meters. So it stretches out to 3.57 meters. So don't get hung up on the way things are worded. Just chunk it and read one little thing at a time and write down that information you're given. Calculate the elastic spring energy. So I want to find PES for the spring. So the first thing I'll do is I'll say, well, what's the equation? So the potential energy stored in a spring is 1/2 kx squared. And the thing is here, this is x. So the x is the change because it wanted to know what was stored in the spring. Well, what's stored in the spring is going to be from the initial to the final. So what I'll do here is I'll find the change, the elongation. Remember, this is the elongation of the spring. So this would be the final minus the initial. So it would be 3.57 minus 2.45. So this is equal to 1.12 meters. So now I'll go ahead and put this in here and say it's 1/2 of K times the change in the elongation squared, so 1.12 squared, and when I work this out, it comes out to be 3.3. Oh, I forgot to put K in. So it's 1/2 of K, 5.2 newtons per meter, times 1.12 meters squared. So a newton times a meter times a meter squared. So this cancels with that, and I end it with a newton times a meter, which is the joule. And then 5.2 times 1.12 squared divided by 2 comes out to be 3.3 joules. Now what you could do is, in this equation, because this is delta x squared, you could just have done the difference in the equation and squared it, but sometimes people make mistakes when they do that. So you could either do it separate or put it right in the equation. And either way, you're going to get the same answer.